Hello students, my name is Professor Muhammad Asim and we are doing ADMath. ADMath for IGCSE students which have syllabus code 0606 and for CIE O-level students which have syllabus code 4037. So both kind of students can get equal benefit from this course. Students, we are doing nowadays past papers, O-levels, ADMath. Topic is integration. We did some questions in previous lectures. Today you can see on your screen we are going to do question which came in October, November 2012 and the code is 13. Start. Given that y is equals to 3e2x over 1 plus e2x. Show that dy by dx is equals to a e power 2x upon 1 plus e power 2x whole square, where a is a constant to be found. This is part number 1. Y is equals to 3e 2x upon 1 plus e 2x. So students, we have to find the derivative dy by dx. If two functions are divided and we find the derivative, then we must use the formula u over v. What is u over v formula? U upon v is equals to v square, v as it is, derivative of u, minus u as it is, derivative of v. So here u is 3e2x and v is 1 plus e2x. V square 1 plus e 2x square, v as it is 1 plus e 2x multiply by derivative of u. U is 3e2x, so e2x derivative is 2e2x and 3 multiply by 2e2x. If you feel the difficulty to find the derivative, kindly go to my playlist and you can see there is a folder name is ADMath. You can find from my playlist chapter number 12 differentiation. Watch differentiation lectures, then you'll have a good command. Minus u as it is 3 e power 2x multiply by derivative of v, that is derivative of 1 plus e2x, derivative of 1 is 0 plus derivative of e2x is 2e2x, bracket close. Simplify it. Three into 2e2x is 6e2x. Multiply 1 plus e2x minus 3e2x by 2e2x. The answer is 6e2x plus 2x is 4x upon 1 plus e 2x square is equals to, now we can take common 6e2x from both the terms, 6e2x multiply by 1 plus e2x, sorry, 1 plus e2x minus 6 is common, e4x. e2x is common, therefore remaining is e2x upon 1 plus e2x whole square. Now see carefully, this e2x cancel by this e2x. So dy by dx is equals to 6e2x upon 1 plus e2x whole square. What was the requirement? Read again. Show that dy by dx is equals to a e2x upon 1 plus e2x square, where a is a constant to be found. So we have achieved our target. Here 6e2x, so a is 2. So a is 2. This is our final answer. Hope you understand. Now see, look at part 2. What is part 2? Part 2 is find the equation of the tangent to the curve y is equals to 3e2x upon 1 plus e2x at the point where the curve crosses the y-axis. Very easy. First, write the equation, given equation of the curve again. Y is equals to 3e 2x upon 1 plus e2x. According to question, this curve crosses the x-axis. Crosses the x-axis means the value of x must be 0, because on x-axis the value of x is 0. So 3e power 2 multiplied by 0 upon 1 plus e power 2 into 0. 3 e power 2 into 0, e power 0 upon 1 plus e power 2 into 0 is e power 0. E power 0 is 1, so it is 3 upon 1 plus e power 0 is 1, so 3 upon 2. So the coordinates are x is 0 and y is 3 upon 2. Okay. Now, for what was the question? You can see again, equation of tangent. So for equation of tangent we need a coordinate, that is 0 and 3 upon 2 we have find, and we need the gradient of tangent. So gradient of tangent we have already find, because in a curve derivative represent the gradient of tangent. So what was our answer of derivative? 6e power 2x upon 1 plus e power 2x whole square. Satisfy this derivative by 0, 3 upon 2. I am writing over here. Satisfy it 0 or 3 upon 2. So we have to put 0 where we see x, and we have to put 3 upon 2 where we see y. There is no y in the answer, so just put 6 e power 2 into 0 is 0 upon 1 plus e power 2 into 0 is 0 whole square. 6 multiplied by 1, 1 plus 1 whole square, 6 1s are 6, 1 plus 1 2, 2 square is 4, 6 upon 4 is 3 upon 2. Now find the equation of tangent. What is the formula of equation of tangent? Y minus y1 is equals to mt. Mt means the gradient of tangent, x minus x1. So y minus y1, y1 is 3 over 2, mt we have find 3 upon 2, x minus x1, x1 is 0. So our final answer would be y minus 3 upon 2 is equals to 3 upon 2 into x, 3 upon 2x. This is the answer of part 2, the equation of tangent. So for equation of tangent, we have to find the gradient of tangent, we have to find the coordinate, and then put in the equation of tangent. Okay. Now move to part 3. What is part 3? See, using your result from part 1, find integration of e power 2x upon 1 plus e power 2x whole square. Very easy. So first we have to write the question. We need to find integrate e 2x upon 1 plus e 2x whole square dx. What was our answer of dy by dx from part 1? Our answer was 6e 2x excuse me, upon 1 plus e 2x whole square. Now if we integrate 6 e power 2x upon 1 plus e power 2x whole square dx, we will get the original equation of curve again, because this is the derivative of the given question. Our question was 3e power 2x upon 1 plus e power 2x. So you can see the derivative of the function 3e 2x upon 1 plus e power 2x is 6e 2x upon 1 plus e power 2x whole square. Therefore the integration of 6e 2x upon 1 plus e power 2x whole square is 3e 2x upon 1 plus e 2x. So that is why we call integration is antiderivative. So now see carefully, we need the integration of e 2x upon 1 plus e 2x whole square. It means 6 is not present. Very easy. This 6 of 6e integration sine 6 is multiplied by e power 2x. So this should be divide on other side. So eliminate 6 from here. E power 2x upon 1 plus e power 2x, and this 6 should be divide over here. So 3 upon 2. Hence our final answer is e power 2x upon 2 into 1 plus e power 2x plus c. This is our final answer. This is the integration of e power 2x upon 1 plus e power 2x whole square. Now what is the remaining part 3? The remaining part 3 is evaluate, and hence means we have to take the immediate help from previous answer, that is the help from the answer of integration. Evaluate integrate 0 to ln 3. Integrate 0 to ln 3 e power 2x upon 1 plus e power 2x whole square dx. So we have already integrated, that is e power 2x upon 2 into 1 plus e power 2x. Now just apply the limit from 0 to ln 3 and simplify it. Very easy question. but systematic. Apply the upper limit e into 2 ln 3 upon 2 into 1 plus e2 into ln 3 bracket minus lower limit e into 2 ln 0 upon 2 into 1 plus sorry, not ln 0, just 0, because the lower limit is 0. I am sorry. 2 into 0 upon 1 plus e power 2 into 0. That's it. Simplify it. E. This 2 must be the power of 3. This is the rule of logarithm. 2, 1 plus, similarly e is ln 3 square. Okay. Minus e, 2 into 0 is 0 upon 2 into 1 plus 2 into 0 is 0. Simplify it. You know, ln or e cancel each other. 3 square is 9 upon 2 into 1 plus ln and e cancel 9. E power 0 is 1 upon 2 into 1 plus e power 0 is 1 is equals to 9 upon 2 into 9 plus 1 is 10 minus 1 upon 2 into 1 plus 1 is 2. More simplification. 9 upon 20, 1 upon 4, taking the LCM 20, 9, 4 5s are 20, 9 minus 4 is 4, 4 upon 20, 4 5s are 20, 1 upon 5 is 0.2. This is our final answer. So hope you enjoy this whole question, which came in October, November 2012, paper 1-3. So kindly do practice more and more and more. In next lecture we will do some more questions of integration, and then we will choose next topic. So student, this is our today's class, where we did question number 7 or 8, I don't know, October, November 2012, paper 1-3, integration. 4 plus 4, 8, 8 plus 3, 11. So this is 11 marks question. I request all of you, kindly do subscribe my channel, and whenever you subscribe, don't forget to press the bell icon button, so that when I upload my videos you will get the notification. Kindly share my videos, my channel, as many as you can. Okay students, best of luck for next lecture.